use variation of parameters to solve the given system. So you are given the system in terms of vector x prime. Okay, now because this is a non-homogeneous solution, first you need to find. So here's a guideline for you to use a variation of parameters to solve the system. First, you need to find homogeneous solution, which you usually do. Okay, so use what? See, if I have vector x prime equal a times vector x, ignore this one. Okay, so basically it is your homogeneous equation, and you can do it very easily. Now, if I add the vector f of t, it becomes non-homogeneous solution. So here's a step you need to do in order to find the answer for non-homogeneous solution. So I'm sure that you learn how to. So this is basically just the formulas from the book or from your notes. So I'm not gonna go over it again, but I will walk you through step by step to get your answer, right? Now first, find homogeneous solution. So let's find a minus lambda I. Let's call this matrix A and then subtract it with lambda I. That gives you this matrix. Then find its determinant. That gives you this one. Distribute this out. Simplify it all the way down and then set it equal to 0. You find out that lambda equals 1/2 and 3/2. Okay. For lambda equals 1/2, plug it into this one. A minus lambda I. That gives you this matrix. Augmented with 0. Okay, you can reduce this down to base matrix, which I get an infinite solution. Okay, so from here I have k1 equal to k2. If I choose k2 equals 1, then k1 is 2, and vector k is 2 1. Then x1 vector x1 is 2 1 times e to the 1/2 t. Now you are going to do the same thing for lambda equals 3/2. Okay, so plug it into a minus lambda I. That gives you this matrix augmented with 0. Again, if you eliminate this down to base matrix, that gives you infinite solution. And then this equation gives me k1 equals 10 over 3 k2. If I choose k2 3, then k1 is 10. Then my vector k is 10 3. And vector x2 is 10 3 e to the 3/2 t. Then my homogeneous solution is equal to c1 times vector x1 plus c2 times vector x2. Okay, so we good. Now for the non-homogeneous solution, first you need to put this into a matrix, and let's call it phi of t. So exclude c1 and c2, the rest will be appear in your matrix. Okay, don't just take the numbers. Now after you're doing that, find the determinant of phi t. That gives you negative 4e to the 2t, and then you need to find its inverse, which is equal to 1 over determinant times a matrix and this matrix. So for the upward diagonal line, you just add the negative sign for the entries. Okay, for the downward diagonal line, you switch the position, so bring this up and bring this down. Okay, then multiply by 1 over determinant. That gives you this matrix. Alright, now let's find u prime, which is equal to inverse phi of t times f of t. What is f of t? F of t is whatever. Oh shit. So your f of t is this one. Whatever left over after you multiply, whatever comes after vector x. Okay. So u prime equals phi inverse phi of t times f of t. Okay, so here's a caution: do not switch the order, because the order of matrices is important when you multiply them together. If you switch the order, that will give you a different answer, and it's not correct. It's not like when you have so when you have numbers or variables, a times b is the same as b times a, but for matrix it's different. Okay, so multiply this together, that gives you this matrix. Simplify it, that gives you this matrix. Okay, so I'm sure you know how to multiply matrices together, so I'm not gonna spend time going over it. All right, now once you get this matrix, integrate this one to get u of t. Okay, so this is constant multiplied by t. When you're integrating it, you just multiply by t. Now for this one, e to the negative t, use the chain rule, that gives you this. Okay, all right, now we're almost done. Hang in there. So now for the non-homogeneous solution, is equal to phi times u of t. Okay, so phi is this matrix, u of t is this matrix. Again, do not switch the order matters here. So if I multiply these two together, that gives me this matrix, and over here it's kind of confusing, but pay attention to it, you will understand. So here's 2 by 2 matrix, and here's 1 by 1 matrix. So 2 by 2 times 1 2 by 1 matrix, that gives me 1 2 by 1 matrix. Okay, so here is 2 by 1 matrix. So this, the whole thing is just one column, and you have two lines. Over here you have two columns, two lines. All right, now it's time to write our final answer. So vector x equal to homogeneous solution, which is this part, plus non-homogeneous solution, which is this part. So add them together, that gives you vector x, and that's your answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.